Welcome back, Math 3 AFM. Today, in this video, I'm gonna talk a little bit about just binomial coefficient and what that is for us and how it relates to Pascal's triangle. But one thing I do want to mention right away: you don't want to miss these videos. So, in this section about binomial theorem, you're gonna find that I've got some really cool tricks. You need to go through these videos and watch every one of them. And I'm going to slowly build up to them because I can't make videos but so long. And this one right here is just sort of setting the groundwork for what we really want to do in the next couple. So let me get started here. And again, taking notes if you want to. It's formatted for you to do that. Just pause and take your time doing it. So this is 8 for continued, the binomial coefficient. And some things I'm just going to review with you because you probably haven't seen this since Math 2. And if you'll recall, n factorial is something that we will need to be able to compute at times, and especially in our next unit when we start doing counting and probability and things like that. So if you're looking for n factorial or how to compute a factorial, I have it down here as what it means literally. N factorial, for example, 5 would be 5 times 4 times 3 times 2. I should have had a 1 here, but I usually leave that out just to not write so much. Then we've got, it's defined that 0 factorial is 1. But since you're going to be doing this with a calculator, you're not going to really run into an issue with that. Okay, so let's take a look at where this lives in the calculator. Go to your math menu, and then go over here to probability. And if you'll notice, number 4 is your factorial. The only thing is I should have put the number in there first. For example, 5, math, probability, and let's say we need 4. And enter. And that's how you would compute a factorial. And if you need to convince yourself of 0 factorial, put it in there. It'll also give you 1. Okay? All right, and the next part of this, I go down here. Now, this is what they call a binomial coefficient. And I know it's been defined other than that previously in Math 2, they would have called this a combination. Remember, you had your combinations and permutations. And this right here would be a combination. Okay, now you're not going to need to compute this by hand. Really, you won't. Not in this class, you won't. So I'm going to show you where to find this in the calculator. And a couple of notation issues really quick. Some books, and you may find this, use this notation instead of NCR. Now, your calculator uses this NCR, and I'm going to show you in a second how to do this. But some do use this notation right here, and just it always goes N comma R. All right, so the way some people even call it N choose R, because the way it's defined is it's a combination or a committee selection. The way to select R members for a committee from among N. All right, so choose a committee size R from N. This is the number of ways that can be done. So that's where this comes in. 7 choose 4. That's probably you're going to hear me saying that because it's a hard habit to break. 7 C4 just doesn't sound right to me. But here's how you compute it if you need to, and you will need to. You would say 7, go to your math, then your probability menu, and it's number 3. Notice there's that P for permutations. You're not going to need that in here. Well, you will, but not today. Oh, this has got a neat way of writing it. I don't know if our yellow calculators look like that. You'll have to let me know. All right, so that's 35. I just said 7 choose 3, not 4, didn't I? And that was a mistake. Well, it doesn't really matter at this point. You know how to do it, but I'm one that has to do things right. Oh, it's also 35. Well, that's interesting. Okay, that comes from Pascal's Triangle. I'll show you in just a second here. All right, so let's go down here. And it's the next thing I want to show you, there is a connection to Pascal's Triangle. And I won't be able to get so involved in this, but I just wanted to explain how these numbers come about from a combination standpoint. All right, because if you'll remember, on Pascal's Triangle, this guy here, a plus b to the 0 power is 1. Now, if you're talking combinations, that would be, here's 0 items. How many ways can you choose 0 of them? Order doesn't matter. One way to do that. Don't choose any, right? If you come over here and you say, okay, here's one item, don't choose any. How many ways are there to do that? One way, just don't choose any. One item, choose one of them. One way to do that. Okay, now it gets maybe a little trickier as we go along here, but you can still see how this works. And these are the numbers. If you compute these with your calculator to verify, this is what you're going to get. Here's two items. How many ways can I not choose any of them? Well, there's one way to do that. Don't choose any. Two items. How many ways can I choose one? Suppose you have a yellow and a red ball. You can choose a yellow or a red. There's two ways to do that. And you just go along here. You can see how this all works out. And this is creating Pascal's triangle. And if you come down here and look at this guy, if I got three items, how many ways can I choose none of them? Well, there's one way to do that. Don't choose any. Three items, how many ways can I choose three of them? Pick one. There's three ways to do that. And turns out this guy will give you the same thing. 3 choose 3 is also 1. And this is the beginning of Pascal's triangle, and just keep on going. So these are the entries on Pascal's triangle. And you can see here that the 3 stays the same in front of every one of these. The 2 stays the same. So I'm going to show you a really cool trick in the next video working with binomial coefficients, so don't miss it. This is just a connection piece in this one. And that's pretty much it for this video. There's no work that goes with it really. It's just paying attention and starting to see how this stuff comes together. Maybe looking at some notation issues. I'll see you in the next one. You can't miss the next one. It's important.